video, we continue to the tutorial for OpenSCAD. We will move to Chapter 3, finish the first part, which we will introduce along with the tube, cube and cylinder. Now this tutorial will introduce a sphere, which like a ball, and also besides the scale we introduced before, we will introduce Resize. So let's do this together. First, in the left is you have this an OpenSCAD overview, the UI, and here is the Chapter 3. First, let's save as. Now we are in the Chapter 3, Part 1. So that is our model. And so far you have used the cube and the cylinder primitive. The third primitive, the model, is sphere. So sphere is like a ball, so starting like just a sphere, and you give r equal to 10. So if we see here, then you get a ball. So that you can notice is the sphere is create the center by default, not like the cube and the cylinder. You need to make that center equal true. So if we let's see, so you don't need to have this r equal. You just have this 10. So because when you have this the open curly, so or open brace, you can see here the perimeter inside the braces is the radius. So you can use either way. You can use by default is a radius, and you can put r in the radius. But if you put d, then that is the diameter. So we have r is the 10. So r is 10 means the radius is 10. But if you put d equal to 10, then that should be, let's see, yeah, let's have this, the finished, the semicolon. You can see now the r is equaling to 5. So that's the difference. If you want to make this a declaration, you need to distinguish r or d. But if you, by default, it will be identified as R. So that's the tricky thing. So, but for this, the exercise, we use this R equal to 10, and you can consider why is not looks the smooth. So you can see. Let's see. So basic, chapter, scale, smooth. Remember here you should have these two, so FA and FS. So one is they are controlling your the surface of the smoothness. So let's copy these two. Oh, sorry. So let me copy that and do redraw. So that you can see now is smooth. So let's put in here. You don't need to do this for now because if you have the PCs with the resource limitation, let's put that by default. That ensures the render. Render is quite preview is quite fast. But in the finished model, you can have this more. So the exercise is try to make the wheel of your car from that cylinder to such kind of the ball or spherical. To do so is replace that cylinder command with a sphere. So that is let's see. So let's copy So you can see here. So rotate and rotate what is the sphere. So let's make our own model here. So recent file. If you see here is our chapter, let's see, chapter 2, part 1, or chapter 1, part 2. So that is our car. So car body, let's copy that. But for this car, it's not good enough because they don't have the parameters. So let's go to the part 2 of chapter 2. So this one, we have enough parameter. We're starting from this one. Copy this to chapter 3. Let's make these comments starting from here. So you can see now you have, let's make big enough. So we have our car here. And then this, let's do this thing. So we have base. We have base is, let's adjust this to 8. And top is 10. So not so the difference of view to that. And what's the track? Track 40, wheel radius 8, and wheel width. What is the width? No. So then this wheel turn is one is 20, one is minus 20. So because we will change that to the sphere, so you will no need to have this wheel width anymore. So and then rotate car base, that is here, rotate body row. So cube center car base here. So how they make this rotate body row? What's the body row? It's the 0. So there's looks like here is no the rotate. So let's and this one is what we have done for the calculating of the translation. So let's move on. So now we have this 4 wheel. So first, these 4 parts. What we will do is this is the cylinder. So we will change that to sphere. And now we don't need this wheel width. So that is the thing. So we will put that comments. So this is for, let's see, for wheel, cylinder wheel. If we don't have a cylinder, then you can comment that. So let's what we I will do is you can consider comments is Control D. So you can come to here, press Control D. Let's comment that. So whenever you want to change your the wheel back to the cylinder, you still have that. So 1, 2, 3, 4. Now what we need to do is we should have our sphere. The sphere is put in here. So let's. What was the radius is what we set here, the wheel radius. So then that will be the same radius than the cylinder wheel. So what we need to do is we will copy this tool. And also the first one. So let's see. Now on the same position, your cylinder wheel is changed to the sphere wheel. So let's save. That is your chapter 1 parts model for now to make this wheel. The idea to use the wheel to create a wheel is very nice. You can now scratch the sphere to give them a more wheel-like shape. One way to do this is scale. So let's do our new model to just to have a look. So this is our part 3. So if you have our the sphere, let's make a new sphere r equal to 8. Remember the semicolon. Then you have this one first, and then what you need to do is we want to have that remember which the axis is a y. So let's do the scale. On x is 1, y is 0.4, and z is 1. And then we can put this with a tab. Let's see. I think didn't have our closing the brace. So you can see that is the scale. Another way is to scale the object is using the resize. So resize is let's make our another sphere. Let's copy this. But just to distinguish this first, let me make a translate. So I want to translate this to x. So x, because its radius is 8, so let's translate to 20. 0, 0. So I should have another ball here. So, and then we can test the resize. What's the resize means? Resize means is, let's see, 28, 20. You can see here. What I'm putting here, resize compared to the scale is I put this finished exact value, not the ratio. This scale means 1 means 100%, so that's the same as the scale, the size of the previous one, and the 0.4 is the 40% for 0%, and 100% means no change. 40% means scale to smaller until 40%. But the resize means is no matter you have what the original one, I want this to be our 3 dimension. The x dimension go to the 20, y dimension is go to 8, 10 z dimension go to 20. So since this our radius is 10, the 8, so let me change that to 10. Then that will be the same, because 10 the diameter is 20, so 20 is 40% is 8. So I suppose I will get 2 exact same size. So that means it's either scale or resize, you can get the same result. But depending on which preference you want, you can calculate just the ratio, or you can calculate based on the final this dimension. So which data on your hand is more easier is you can use which one. So we test this, and then we are moving to our exercise. So this one, I will put that as also to give you our part is save this to chapter. This one is part number 2 model. So you can also have this compared to between the scale and resize. So I close that and back to here, resize, and the read preview. Then try scratching the spherical wheel to your car along the Y scale. So Y scale is here. So what we need to do is remember this rotate. So let's say here. One thing is you'll see here is we have a sphere and we have the rotate. But actually this rotate, you can consider even we leave this rotate, but things for our sphere is no matter. So then this one, actually we should also comment that. That is for the cylinder purpose. Let me make these comments. So let's see here, if cylinder wheel and if sphere wheel. Then for sphere is we put rotate is no meaning. So but we want to ensure is for cylinder you have the rotate. So even on the exercises here, rotate 000 is nothing. So just so we don't need to do this rotate for your purpose. So let me copy this. What I will do is if you go to your this file, if you want to return back to the cylinder, you can have this part uncomment. If you keep one as the sphere, you have this area. And now is we will start to do the resize. Resize is coming to this ball. So first we have this ball, and then we do resize. And this ball, the radius is the, let's say 8. So if we want to do the resize, we will see the how which is the target we want to have. So we want to see the 16 on Y is maybe 4, 16. Let's just have a look. Well, what that means. Putting this inside. So let's see. Is this good enough? Or is too small? Maybe we go to 20. Let's see. That looks a little better. So let's make all of them here. So you put this, you put a tab, and these are the code is looks busy, but that is due to is we have several the repeatable areas. So we can make that clean when you have longer the program. But now what you have done is make your this wheel is back to this scratching. So let's check the part. So resize. So what they have is they are using the perimeter. So that means is they have double the radius, so they come to the diameter, and then the this the in the Y is the wheel and the width. So so they have this wheel width still. So that is we can make this back. So we still use this one is 10, and then let's see. So this wheel width is we put at 4. So we can copy this one to replace ours. whenever you can use perimeter, try to use that instead of this hard coding. So then we can just adjust our variables. So let's see. It's not look big enough because it's well, we are putting our the body is not so this wide. So let's double check is 10 base height, base top height, and what's this resize. So they and translate 60, 60, 20, 30, 20. So that's it. And the track is 40. No, it's 30. So it's too long. So let's change that. Yeah, now this looks quite similar to what's this model. And we don't have this rotate. So let's see. So rotate body roll. So body roll is let's see, body roll, car base. So let's see. So body roll is 0. So that's no change. And what's this front heel? And translate rotate. So here wheel turn. So we should have our this rotate now. So rotate, wheel turn, the back, the rear wheel doesn't have those. So we don't have that rotate. So front wheel rotate. So let's see. So in the front wheel, we will have this one. So rotate. So let's not comment that. And then let's see. You see a little tricky thing. So it's rotate on this part. So 0, 0, because for those we cannot directly use this kind of the cylinder part, because cylinder is have the 3-dimension difference. So let's see, here is rotate. X and Z should be the no difference, and then just front. Let's copy here. With this the dose bracket and close this brace. Then let's double check. Yeah, that's great. So now we have another rotate for the front right before resize, and as the good the behavior is just keep adding those into another tab, so that people can see this is your the transformation. And also I will keep copy this, because I also have another rear wheel. So I have made this in the different direction, and then this you can copy. Ensure you don't have a semicolon after that. Otherwise, that will generate errors. So now redraw. So you can see here we have the two return. One is the minus 20, and another is 20%. So those are the things we have used. And then this last part is let's do the sphere for the body. So now our body is the cube. So we want to change that to sphere. So let's go to this body part. So let's make our the cylinder body. So let's copy that. We want to use a sphere body. So let's comment this, Control D, Control D. So what we need to change? So this is the cylinder. So cylinder is the 60/20 base height. This is the the size. But if we have our the ball, so first is let's make a ball. So the ball we put that in the base height. So sphere base height. So height is the diagram. If I just guess. I have this first, then I don't have this, I will do the resize. Resize to this. Let's have a look. So resize to base height. Oh, here I should not have this the dose bracket. So let's have a look. So it looks like it's not so heavy, so because we need to have certain things, is 20 looks like it's quite small, so let's make that 40 first. In our base height is the, so let's see the those x part, x and y, this is x, this is y, so height is not big, so let's double that. Yeah, you can see is you can control the thickness of that. Let's make this to 3. So that's I think it's 2.5 will be good enough. So that is our part, and also here maybe I put 30. Too big. Oh, so 25. And then the second one is also similar. So we need to ensure is you have that translate still. So let's between that is we have a sphere. Let's see now the dial base is top height, and then we have our resize. Change this to resize, and this also time 2.6, 2.5. Let's see. So what we are putting is you have that change and make this enlarge and connect it into your car body. So let's compare what's the sample model doing. So rotate body roll and the car body resize. So they gave our just the exact this figure. So first they gave our sphere is R is 10, but what we use is base height. Base height is 8. So that is no matter, because actually when you do the resize, the original R or D is not make any matter. The matter is this final this kind of the size. So they have 90, 20, 12, but we use this the 8 times 2.5 is 20. So where looks bigger, and also they have this 10.05 and do the translate. But this translate is I recommend is you can keep this because this may not be needed, because your now is the sphere is not like the exact edge like a cube. So you can put this just like simpler. So let's see. So you put that 5 is inside that. Remember is what we can do is you can make this transparent to have a look. So what we have done is the upper the sphere is inside a lot of this the body. So, but as long as they are not coming out of from the bottom, you can leave that. Or you can, like this is you don't need to make that so heavy, so so height. So let's see here. Let's change that to 12 or 15. So that is the and then here, let's see, just to the 2. That gave you some the different things, and also for here, let's make that higher on the Z. So that coming outside more, but maybe it's this shape. So you consider a car, you need to have considered the some physical the rules. So make that little inside is will be better. And then remove this transparent. So that is your car. Looks like something is some car in the conceptual the car and coming from future, so not like today's car. So let's put this as our part 1 complete. So you can adjust the dimension to your expected one, but no matter which one, you can save that. And what I will do is I will try to close this. And come to the file. Let me do our rename. So part 3. So this is our first model. Then let's do open this one. What I will do is you can now do the render. Waiting just a second. So you can see now, because we are making this quite smooth, so it will take some minutes. Let me pause that. After rendering, you will get this the nice the rendered card. Then what you can do is you can now export that to the STL. Then you can save and close your the files. Then what I can do is I will put that at tutorial 3 part 1. Go to the GitHub. What I want to introduce is the interesting thing is last time is I mentioned to you is on the Visual Studio Code. If you have a model file like this, we have this file. You can add our the plugin from this market. Then you can preview this STL as the model. That also are similar the feature in the GitHub. So if you come to the code and if you see what I have just posted is this STL to the GitHub. By default, this GitHub also have the preview. So it's also look in the nice part. So you can zoom in, zoom out. If you just make a good the size and just leave it, it can be rotate themselves. So that is quite nice for you to export to our STL model file from your OpenSCAD format. Then go to either the VS Code or go to GitHub to have the preview. You can also see I want to see the wireframe, I want to see the surface angle, or the solid like this. So 3 types. So I hope you till now you can enjoy those the built-in the type. For the next part is we will analyze some combination the methods for union or the minors, so that you can start to actually create some customized the shape or object. Thank you for watching.